All right, let's go. Hi, my name is Ricky Holston. I'm the webmaster with the Arizona Water Distribution Committee, as part of the Arizona Water Association. We've been doing these monthly webinars, excuse me, as a way to supplement training because we can't meet on in person, to hopefully get to the membership and as a way for them to get credits and learn something new on the education side of things. Last month we talked about saving money pumping groundwater. The sponsor there was Hose Solutions. That they had a great presentation on flexible column pipes for using in wells, and they looked at an analysis of what would happen when you use different column pipes, and basically you have reductions in pumping because of clogging in the column pipes or other inefficiencies in your system. So if you have some place that has a well and you have some column pipe issues, then Hose Solutions is definitely worth a try. Go check them out. They're great people, and they'll be happy to talk to you. So you can see them at hosesolutions.com. Okay, this month Rockwell is giving a presentation on digital transformation that enables smart water solutions. They'll be looking at how the computer age is coming into the meeting the old water systems and wastewater systems, and what we can do to digitize things and use that data to make better decisions about how things are run. So Mitch Ray is with us, as well as Janine Nielsen and Dean Schmidt. I get that right?
It's shite, but
You were close.
very good. Good introduction. So.
All right. So please kick it off, guys. We appreciate you being here.
Thank you.
Yeah, thanks, Ricky. Good afternoon, everyone. Thanks for joining us today. My name is Mitch Ray. I'm an account representative with Rockwell Automation, and we'll be going through digital transformation enables smart water solutions. Feel free to drop a question in the chat. We are going to allot 15 minutes towards the end to be able to have a Q&A session. But I'll be collecting any of the questions that are in the chat for later as well. Thank you.
As Ricky mentioned, doing our presentation today, myself, Don Rafflick, I'm the Rockwell Automation representative for water, wastewater in the Arizona territory. So at any place in Arizona, as well as outside of Arizona as well. Mitch Ray is the account rep for water, wastewater. Janine Nielsen is our business development manager for water, wastewater throughout the South. And Dean Schmidt is our process consultant. So Janine and Dean will take it over from here. But I just wanted to tell you who was on the phone.
Great. Thanks, Don. Can you guys hear me?
Yes, we can.
Great.
Yes.
Okay. Awesome. So I'll go through the agenda. Hey guys, again, this is Janine Nielsen. I'm the business development manager for Rockwell Automation for water, wastewater. Very excited to be with you all to share our insights around digital transformation and smart water solutions. This is the agenda. We'll be speaking about the factors driving this transformation. I will share with you the trends in the water market and how do we get smart in smart water, and some of the building blocks that we see that is paving the way for smart waters: digital operations, system reliability. Sorry guys, can you hear some background noise? If you guys can mute, we'd appreciate it. Thanks. Can you guys hear me?
Yes, we can.
Yes.
Okay, great.
Yes.
Sorry. So some of the building blocks that's paving the way for smart waters: digital operations, system reliability, remote operations, and when we talk about digital or just being connected, it's also protection against security threats. And then to Mitch's point, we will leave some time for Q&A at the end. So here are some factors driving the transformation to smart water. And some of you may have heard smart water, digital water, Water 4.0. These are names given to digital technology-based innovations currently transforming the water sector. And you can see here, just against this backdrop, there are some challenges in this water sector that digital water solutions can help with some promising solutions. So if we go from left to right and we're looking at population, with population growth, urbanization comes supply challenges, and we're seeing that an increased demand by 2050, 70% growth of projected, and this is for the world, 10 billion in population. And that is including a very water-intensive emerging middle class. So population growth, rising housing, all of that is a factor accelerating to smart water, and some ways we can help support that. Another serious challenge is climate. Because of the global population growth, there's also a global water supply demand. And one of those factors is climate, is also climate, right? And so regions are prone to flooding, rising sea levels, contaminant, fresh aquifers and farmland. And drier regions, you can see droughts becoming harsher and more frequent. So again, this problem is exacerbated by the fact of what I just spoke about with population growth. Going from left to right again, in the middle, we see regulation, and there's going to be new laws imposed in this sector, and just an increased requirements for compliance. And it's really to, protect the public. And so there are ways that we can help with optimizing the efficiency to comply to these regulations. And then infrastructure, what we've seen, 2/3 of the plants out there in the US are over 20 years old. So to take advantage of the emerging technology, we must first migrate these facilities to the current technology. And then the last one is workforce, and it's very important because it's about our people. And this is also a challenge, not just in water, but in every industry. And we see the tribal knowledge that will leave this sector because of retirement. And, we're saying goodbye to those individuals that in their mind, in their brain, they have knowledge of miles and miles of pipe systems and how a water or wastewater plant is operating or operated. Now we have a generation in the workforce that is educated, trained, taught, managed, using data very differently. And so we need to find new ways to capture, replace that knowledge so it can benefit the new workforce. I thought it'd be interesting to look at some of these issues as we get out of the pandemic. And the first one is population growth. And as you can see in this map, the green are states that has seen population growth. And you can see Arizona's there as one of the top 5. And I'm sitting here in Los Angeles. And for the first time since the early 1900s, California's population growth dipped. And there is an exodus to the states that are east of California. And I see that here in our market, and also traveling when I'm there supporting Dean and Don and Mitch, and we see the other states, we do see the population growth in the greener states. So that is something to look at as we support the infrastructure for that population growth. The labor force, when we look at our workforce, because of coming out of the pandemic, remote workforce was a luxury, and now it's a necessity, offering greater flexibility with the employee, and also looking at some areas where we can automate and help optimize the remote workforce. And then climate resiliency. The pandemic has really spotlighted water, sanitation, and hygiene. And, the country has acknowledged that water is essential. So, kudos to our water, wastewater providers in keeping the water flowing through this crisis. I know our neighbors in Texas, when they had their deep freeze in February, they were prepared for a water outage, for a power outage. But lessons learned, they were not prepared for a sustained water outage and power outage. So they're looking at investments to be more resilient when it comes to these climate events. We're also seeing investments in smart water. So in the left, you can see the increase of project activity when it comes to digital water project activity globally is up 32%. And then in North America with US and Canada, there are expenditures for 6.5% CAGR up to 2030. On the right, you'll see a chart and a forecast. And these expenditures are broken out by software, services, and hardware. Traditionally, there was a significant investment in hardware, but you can see the makeup is going to be changing between software and services. Yeah, and this was also interesting. I wanted to put this map here as we look at, who's leading the way to digital innovation. So hopefully you can kind of see the colors here on the top right of the map. And with the dark blue states, that is leading the way in digital water adoption. But you can also see Arizona being the light blue, that Arizona is definitely primed to be in the position for digital water adoption. The bottom chart, I highlighted Arizona being above the line, which means, again, a very prime position for innovation against how that would balance out with your infrastructure and operational challenges. So I think this was something very interesting, especially for Arizona. The states that was looked at as far as digital, leading the digital way was the amount of water projects, digital water projects, the number of digital water solution providers that are headquartered in that state, the number of innovation clusters that are active in that state. Also, we're part of an industry organization called SWAN, which is a Smart Water Alliance. The number of utilities participating in these progressive focus industry groups around SWAN. So this is, that report of those states that have adopted digital innovation. So when we look at smart water, there's also opportunity here for a connected city or smart city. And, combining data across the agencies using smart sensors and devices that you see here can benefit the overall ecosphere here of the smart cities. It helps enable holistic planning, reduce costs, and really improve quality of life. So you see that innovation, not just in water that we spoke about, but you can also see that just across the utilities, and it really helps with some new possibilities of collaboration and innovation across the utilities and beyond. So when we talk about a smart water plant, there are some benefits sorry about that. There you go. There are some benefits when you hear about the IT and the OT layers converging. And some of the benefits that you see with that IT/OT convergence, and you may have heard the industry of things, or I'm sorry, Internet of Things, or the industrial Internet of Things. You can really take advantage of just across the enterprise operational intelligence, really making decisions, having real-time information to make those accurate decision making. Digital workforce, again, I talked about optimizing the workforce, having data-driven decision-making at your fingertips so your domain experts can, make a decision. Intelligent asset utilization. We're going to talk a little bit more about just asset management, anticipating failures. We have some solutions that's out there in the market for pumps and fans and different areas in the water and wastewater treatment process. And then process optimization. You're going to hear a lot about in the market there about AI and digital twin and augmented reality, and those technologies are available in the market. And Dean will be talking about an example of a condition-based monitoring that we've seen. So when we talk about scalable analytics, there's descriptive, diagnostic, predictive, and prescriptive. And currently, as you look at this left column here, currently this is where we see our market, where there's a device. We do have trends, charts, alarm banners telling us if a pump or a device is running okay, is the process running okay, is the plant performing at its best. But if you look from left to right, Nirvana is really looking at not only is the device and their status and is it running okay, but why did it fault? Can I predict a fault before it happens? And then what action can I make to avoid the fault? So these type of analytics are available in the market, where now you can have actionable insights in near real time. And this predictive model for failure is it's only valuable when it comes early enough to avoid a failure. So as you look at implementing smart water programs, you're probably thinking, okay, if where do I focus my investment? Where do we start in our digital transformation? And here are the things that, and I mentioned building blocks here. Here are some of the building blocks as you pave your way to smart water. Digitizing your operations, assessing your reliability and predictive maintenance programs, and then also optimizing your remote operations. And security should be baked in throughout this whole digital transformation. So I hand it over to Dean Scheit.
Thanks, Janine. Appreciate it. I've been at Rockwell now 30 years, and I've been helping water and wastewater customers specify, implement, support, maintain, upgrade, facilities during my entire career at Rockwell. And one of the things that I think there's been some step changes in my career, and I'm extremely excited about kind of the current step change that we're in today. So with all the intelligence, and Janine mentioned the OT and IT convergence, that's really the operational information and the IT informational business systems needing to communicate stronger, more securely. But the fact that devices now have so much intelligence built into them, the semiconductor industry that allowed us to create, devices even down to the instrument level that can basically tell you their health. It's just an exciting time to be in the industry and to be considering trying to move into this next paradigm. So one thing I'll focus on, next slide, Janine, focus on is, the whole idea with digitizing operations. Why do you want a smart water plant? Janine mentioned that the skilled workforce is tough to maintain. A lot of people are aging and retiring, and the workforce that is being brought in has a different skill set. And that different skill set, a lot of younger folks have been brought up basically with computers their whole lives. And so the information that they're just used to and that they expect is part of this digital transformation. And so they're more well equipped to be able to kind of deal with these kinds of technologies. But Janine mentioned a couple of times, the whole idea is, I've been into a number of facilities, whether you're a small municipality or a very large one. Most everybody is one of the key metrics that that they look at to kind of gauge the operation is trend screens, trending of influent, effluent, all the different KPIs that you may be looking at. But the idea here is that trends are like stock prices, and trends are typically things that have already occurred. So when you're trying to make real-time decisions, you're making those real-time decisions, but it's really based on something that's already happened. And so the idea with digitizing your operations is how can we take that information, as Janine mentioned on the one analytics slide, how do I go from kind of on the left-hand side of reacting to conditions to predicting what those conditions can be. And that leads to better visibility for plant managers, operators, supervisors of these facilities. It allows you to make better decisions. It allows you to reduce chemical usage, all those kinds of things that come into being able to predict what happens. For people that are, supervisors in a facility, maybe you have better controls over your maintenance departments and how quickly you get things done because of this amount of data that you can utilize. So digitizing the operation isn't necessarily just providing a lot more data. It's actually putting that data into the right context. And so you may hear about this, it may be described as a single pane of glass. So if you hear that comment in the industry, what that really means is putting the relevant data that helps you make a decision. So think of it like your Apple Watch or maybe your Fitbit or Garmin wearable device that's keeping track of some of your health and exercise data. I mean, it is data, but it's in context of, how far did I exercise? What was my heart rate? How well am I doing overall? So it puts that data into context for you. And that's really the idea around digital operations. Next slide, Jenny. In order to get this digital data, this massive amount of data that's available, and I would say that plants have been gathering data over the years and more data as networking of the automation architectures have come out. But it took a lot of programming work to make that happen. And today, with this digitization or these smart devices, a lot of these devices can communicate over a solidified network that allows it to basically produce data that people can consume. And so when you're trying to digitize your operations and move yourself closer to a smart facility, the network infrastructure becomes the key element. And if you have a weak network infrastructure, you're not gonna have good results when you go to try to digitize. And so these smarts and this networking technology and capabilities goes all the way down to down at the bottom of the slide there under the legacy and intelligent assets. It goes all the way down there to the skids that come into the facility that maybe an OEM is providing some sort of filtration skids, all the way up to the upper level networks where maybe maintenance people might be using. On the far left, there's a little, looks like goggles, visualization, alarming, and reporting. Well, that could be your traditional HMI or SCADA system, but it could also be new things like digital training where maintenance and operations people can wear these, HoloLens goggles. And within that HoloLens, you have a virtual facility that mimics, or it's a digital twin of your plant, and they can do all their training utilizing that. So it really increases the operational effectiveness by having these digital twins associated. And you get those digital twins because you have this rich data that's available. Other things, including work order management. A lot of companies may have a automated work order management system. Some people may have just a time-based work order management. In other words, maintaining the equipment on a specific time base versus a condition-based algorithm. But again, having this smarter data will allow you to optimize that. Janine mentioned a little bit about the analytics. We're starting to see in the industry analytics being used for things like optimizing the digestion in a digester, so that you now have the optimal point and the optimal O2 levels and those kinds of things. And it really tries to increase that percent of operational effectiveness out of those devices. And that's all done through analytics. Most plants will still utilize historical data, LIMS systems, so quality systems, those kinds of things. But what we're seeing in the industry there is that data is moving off premise and moving into the cloud framework. And so, having that secure digital connection becomes ever more important. And then another one here is environmental and energy monitoring. Because a lot of these devices have the ability to monitor their energy, they become little power monitors essentially throughout your facility. And now you can start to kind of map and monitor, how can I utilize this equipment more effectively to reduce my energy usage, maybe reduce my carbon footprint as I'm operating my plant. So those are all aspects of the digital operations, and you need a solid Ethernet architecture to get all that data. There are sub-elements of the Ethernet architecture. There are instrument level networks and specific device level networks, but they all essentially join in on an Ethernet backbone. So the operators and or I should say the maintainers of the systems in the future will have some sort of background in networking technologies and those kinds of things, because that's just as important as a maintenance person that understands what a 4 to 20 milliamp connection is into the control system. So the workforce changeover that we were talking about earlier, those are some of the technologies that the skilled workforce will have coming in. So anyway, so I just wanted to spend a little time just kind of laying that groundwork. So Janine, go ahead and hit the next slide. I'm going to talk a little bit about reliability. Obviously, reliability is the utmost important from a depending on what kind of redundancy you have built into the facilities. Obviously, reliability is important because you have consumers that need to be able to operate, and they need to be able to drink water, and they need to be able to flush water through the system. So next slide, Janine. One of the things that is done in almost every water or wastewater facility is everybody has pumps, and sometimes these pumps can be in the multiple hundreds of horsepowers, and those pumps and motors that correspond with those are not typically things that you get off the shelf. They typically have some lead time associated with them. So in a lot of facilities, you may have kind of redundant pumps and those kinds of things just in case. But almost everybody that I deal with has some sort of what's called condition-based monitoring system that affects their reliability systems. So they'll monitor, they'll go around with a handheld data collector, so a little device you hold in your hand with a little magnetic probe that gets stuck onto these pumps and motors. And they sit there for a few minutes, and it records the vibration signature coming off of these devices. And you could have vibration from a pump due to cavitation. You can have vibration from a pump motor combination from being misaligned. There's all kinds of things that can cause different vibrations. But these vibration signatures that get recorded by these handheld devices are very specific to what's going on within those physical apparatuses. And so even things like the number of vanes on an impeller will produce a very specific frequency. So in some organizations, you might have a reliability office or reliability folks that go around and do this data collection. And some of them may be trained in higher level vibration analysis. And so they might look at these things and determine, oh, we have a bearing that's going bad. And so you're kind of trying to predict, being able to shut something down on a scheduled basis versus having it fail on you without your knowledge and causing much more expense. So every pump, every motor that are used in a typical water or wastewater facility may or may not need this type of monitoring, but usually the larger horsepower devices do. And so hopefully you've run across this before. Next slide, Janine. So one of the things that occurs is, what if you could take that handheld data collection, walk around, let's go collect this data, and then analyze this data. What if you put that data into the arms of the operators. And the operators don't necessarily, they don't have to be trained in all these different technologies, but they at least understand if there's a problem or not. And so these are just some graphical screens on this slide that talk about, if you look at that very upper right hand picture there, we show some bar graphs with just red, green, and yellow kind of bar graphs. And those bar graphs are just an indicator to an operator, hey, I'm having an issue here. There's some red on my SCADA screen here. I better alert maintenance to go check this out, or maybe I alert the reliability department to go look at this. So these are just examples of what can be done when you start taking that data that's already being collected by hand, and now maybe you, instead of making it a magnetic connector that's on there, these motors and pumps come with devices that can be permanently attached to those, and those devices that measure these vibration signals basically get brought into the control system. So you may or may not have stuff like this in your facilities already, but one of the things that we're doing with this is we're taking this technology, not just Rockwell, but a lot of manufacturers. What we're seeing in the industry is that they're taking this technology and saying, okay, so this is a lot like taking a trend of what's currently happening. How do we take this trend of information or this machinery signature that we know and predict what's going to happen in the future? Next slide, Janine. So one of the things for people that are currently using some sort of condition-based monitoring program, they're seeing a lot of valuable benefits, and those valuable benefits come in a number of different areas. Things like increasing the mean time between failure. So this is data that has been provided from a data source called Plant Engineer's Handbook on motors and motor failures and those kinds of things. And so that, they say that 30% increase that you get by monitoring these types of things continuously versus walking around with a handheld data collector could improve your operations within 30%. Improve the pump or the machine's uptime. Okay, decrease your maintenance costs, because we all know, or for those that are in a plant and run a plant, that the maintenance cost significantly increases if you have to do emergency maintenance versus scheduled planned maintenance. Okay, so the whole idea here is by doing that, you can get better and tighter controls on your facility. So next slide, Janine. So now imagine if I'm taking that data, and because of the ability for devices now, these smart devices, you may have heard of artificial intelligence being discussed. Almost every software vendor, from Microsoft to Google to all the automation vendors, are working on this artificial intelligence. And so what does artificial intelligence bring to the table? Well, today, if you look at this slide, you still have the devices on the left hand that's called vibration sensors that bring data into the automation system that allow you to continuously monitor it. But there's a block in the middle, this automated learning system. So this artificial intelligence system that comes into the middle of it. And what that is normally, if you have any reliability engineers that have been highly trained in diagnosing and determining these fault signatures coming off of these physical machines, it takes some of that domain expertise of what those folks had or have, and then it puts it into a mathematical model inside these automated learning devices. Okay, so you can think of it as an edge compute device, or you can think of it as just an I/O module into the automation system. But the whole idea here is the automated learning that goes on with these determines and learns the type of pumps and motors and the operations that you have. And over time, it continually learns kind of what's going on within the facility. So remember, I said that, wouldn't it be nice if you could take this trending data and predict what could happen, 1 week, 2 week, a month, 2 months, 6 months out? It has the ability to do that. So if we look at kind of the simplifying the CBM, or the condition-based monitoring, that's that online monitoring that you're doing all the time. It allows you to embed that domain expertise in that AI engine. And then if you do have reliability engineers or maintenance folks that are specially trained on working with vibration, they can focus in on the root causes and not have to spend their time trying to deal with isolating what the cause is itself. They can work on it and produce results directly from that. Next slide, Janine. Let's talk. Janine mentioned a couple things. With COVID, we said it was a luxury working remotely, and now it's kind of becoming a necessity. So one of the things that we're seeing is a lot more people asking about how do I do this securely, and what are some things that are happening in the industry. And the first thing is, years ago, when people were putting an automation system, they would put a desktop PC, and then they would load an operating system, and on that operating system they would load an antivirus system. And typically those PCs had hard drives, spinning hard drives. They all had USB ports, and people would plug into the USB ports, and then they had all their software apps that you'd have to load. And imagine as your plant gets bigger and bigger, you have that in your control room, and then you multiply all that effort throughout your facility. Okay, so wherever you have some sort of operator interface into the SCADA system or into the plant control system, you have that throughout. So you have multiple times that you have to patch the operating system or upgrade the application, maybe control user access to the USB ports, all those kinds of things. So one of the things we're seeing in the industry is companies moving to more of a client server-based architecture versus all those standalone pieces. And what does that allow you to do? Well, it takes all those operating systems that you had to load on all those different individual PCs. It takes all the apps that got loaded on those. It takes all the antivirus stuff and allows you to just load it on a central server. And so you really reduce the number of instances of where you need to provide support. And so now that you have this support handled, you've got one OS that you're migrating or patching, right? So you got to keep up with security patches. If you have to upgrade the app, you do it in one spot, not 10 spots. And likewise, you have one antivirus system. So what's going on is this little weightlifter guy in the blue squares there. That weightlifter guy is a technology that allows folks that are putting all this content in servers to push that content securely and remotely to anywhere within the facility, or even remotely through a remote connected user. So if somebody was at their home and the IT and OT folks got together and talked about the network infrastructure that allows me to connect in remotely through some virtual private network, I have the same access as if I was in the control room, standing on the control room floor. So unlike Oldsmar, which had a remote user connection set up that was very insecure, this is a very secure method of doing it using this technology. So you can't just connect in as anybody. It would be like logging in as if you were in front of the terminal. So, and you don't have a generic login or anything like that. So go ahead, next slide, Janine. So what's nice about the technology that's being used today is the boxes in the red up at the top there that say HMI, CMMS, all that. Those boxes are the sources of content that this software platform can produce out and produce to all these clients. And the clients don't have to be full PCs. The other beautiful thing about this technology is you can reuse old technology. Let's say you have some Windows XP or Windows 7 boxes that are in your facilities, and normally those go through a refresh cycle. So IT would cycle those out, or the operations folks would cycle those out and get new Windows 10 machines in. This technology allows you to reuse those old ones because we don't even use the operating system or the technology. I shouldn't say we. The technology doesn't use the operating system. It actually pushes the content from the servers, and it pushes that content to essentially just a terminal mode. So these old PCs can boot up in a terminal mode, and then they get their personality sent to them from this remote connection software piece. and it'll send the SCADA screens, the HMI screens, your maintenance management system. You know, if you have someone walking around the plant, it'll send it to Android devices, Apple devices. So now we've seen in the industry multiple times where plants have an infrastructure, a network infrastructure that's an intranet, not externally available. But when you're in the plant, somebody might be walking around with a tablet or their own or an iPhone that they can connect, bring your own device, and then that user, no matter where they're at within the facility, that source of content that's assigned to that user goes wherever he goes or she goes. So it's a really interesting technology. Go ahead, next slide. There are other things that are occurring in this digital smart plant capability, and this is just a screen of a web page that all these devices that are in a plant have the ability to produce data up to just a web interface that gets customized by user. And so in the red box there, you see that there's a device called a PowerFlex 525. That's an AC drive, and it actually is producing data saying maintenance is required. There's some sort of fault on it. And that took no programming by anybody, no systems integrators, no manufacturer. You just hang the device on the network. This box sits on the network and automatically collects this data from smart devices. So, and notice there's a vote up and a vote down. So if Dean's a user and I'm assigned to this area of the facility, I may not care about VFD faults or VFD issues, so I can vote that down. Or maybe I do want to see them and I can vote them up. By voting up and down, swiping left or right, I now have the ability to control what I see. Okay, so as a user, it improves the maintenance. Now, that same notification can be pushed out to cellular and mobile technologies, Android, Apple, and I get the same type of capability to see something needs to occur right in my device that I carry around with me. So no matter where I am at the plant, I can get a notification of an issue. So those are things that we're seeing from a digital connectivity from a remote operations perspective. So imagine, here's a control room here, but imagine if you had software that oversaw all this and could alert your teams like what I just showed you of abnormal situations, right? So, hey, I have a problem. You may need to go, look at me and see what's about to happen. Okay. What if you had systems that could, determine what happened with maybe a lab sample? Something that notifies you of equipment downtime, something to increase all this data that you have while reducing your energy I mentioned earlier. The whole idea here is that you can do this. It is happening, as Janine mentioned in her slides. There are some states that are moving a little further ahead than others in terms of implementing these things, and they do it without having to have all these data scientists. So data scientists are another industry all by themselves that look at all this data and then rationalize the data and figure out future trends. Next slide. So let's talk, by doing all this, let's talk a little bit about security. So on the left-hand side of this picture, you have your operations. You've got these smart devices at site A, site B, site X. All these devices are producing data. They need to be securely connected into the enterprise. So this shows a little picture of a firewall and a little lock there. There are technologies out there today that can scramble the information so that if somebody was sitting in the middle between the red and the green dashed boxes and trying to intercept your data, it could be scrambled. But the same thing goes all the way up to the cloud. So how do you do this securely? So there are technologies and white papers that talk about the infrastructure that you need to make this happen. And up on the top of the slide, you will see things in the industry called plant-wide Ethernet solutions, or CPWE. You might see documents from leading firms, Cisco in the networking environment. Rockwell works with Cisco a lot to come up with these pre-configured and pre-tested network validated designs. Next slide. So the whole idea, there's an attack continuum that you need to look at you need to identify before you start to upgrade your facilities, or before you specify what you want. You need to look at things during and after. And so there's different aspects of what you look at. I'm going to focus kind of during, I'm going to focus in on the detection side here and just mention what's occurring on the detection side. So real-time threats, how do I identify if something's occurring within my facility, and what tools are currently out there today? So the next slide. If you look at this next slide, there are either pieces of hardware or software that's out there that can passively monitor all the communications that are occurring on that network infrastructure that I mentioned earlier, that learn kind of the network patterns and the types of traffic that occur and all the different protocols from all these different automation vendors out there. It learns all that, and it can tell if there's something that's out of that spec, and it will notify people, the appropriate people, if something is out of normal. So it continuously sits on there and just monitors the system. So those are things that are occurring today. Next slide.
Thanks, Dean. We would be remiss if we didn't talk about the recent cybersecurity incidents at the Oldsmar, Florida plant, and also Colonial Pipeline. As you can see, there are some legislation and laws to help support this sector. The America's Water Infrastructure Act of 2018, this requires all community water systems serving a population of over 3,300 to consider cybersecurity threats as part of a risk and resilience assessment, and also for their emergency response plan. So you can see, based on their utility size and number of water systems, there are deadlines to submit into the EPA in regards to the risk and resilience status, and also the municipality's plan and emergency response. The other thing that just currently happened on May 12th, the president also signed an executive order to improve the nation's cybersecurity and protect federal government networks. So hopefully this will also benefit both private and public entities. Again, cybersecurity should not be an afterthought as you go through your digital transformation. It should be planned. It should be part of your plan into digital transformation.
Okay, so to wrap up here, you've heard a couple of things. Obviously, smart water, smart city is going to take a lot more than just 45 minutes of your time to really go into depth of it. But things that we're interested in, obviously, is unifying your infrastructure, right? Connecting stakeholders in very relevant ways, getting everyone connected, all your components connected, everything talking to each other, and providing you the things that you need to do to make life easier for you, and improve speed, decision making. Right, very important when you're able to predictively do an outage rather than than reactive, right? So those are kind of the things some of the things we talked about, and the whole thing is rounded up in making sure that we have a better bottom line for you guys. So that's basically where we sit. Next slide, please, Janine. So we want to thank you for taking the time today to listen to our presentation. And this is a great time for questions. So if anyone has any questions, I didn't see any questions in the chat. But if anyone has any questions, it'd be great to get those now if you have any. No?
Oh, I have a question.
Yeah.
People in the existing SCADA world, they're operating off the network for security reasons, so they're using all radios. They could set up it sounds like they could set up a network, a smart network, and hook up their SCADA to that, and that could serve as the data in the smart network part, and then put the alerts back into SCADA. Is that kind of how it goes? Or is it bigger than that?
This is Dean. I would say it's a little bigger than that, but that's a starting point. We're not saying you have to get rid of your radio networks to, if you have long distance communications to a remote pumping site or something, those don't all have to be necessarily be put on, some fiber connected Ethernet. The idea is as you still have these radio communications, what you're seeing in that industry is wider and wider and faster throughputs on that. So, it still might take some upgrades in technology to get the bandwidth for smarter information to be transmitted over those radio signals.
Okay.
This is Janine. Hey, good question, Ricky. Thank you for that. And we want to make sure that, we have small, mid-sized, and large municipalities in this sector. And what this means as you go into your digital transformation and just taking advantage of emerging technology, it doesn't have to be an overhaul of your SCADA system. You can still use your radios. You can still use your existing processes. I think the first step is really what we always say as our mantra is really just assessing what's connected. And then once you get your assessment, then you can look at it and go, okay, here are some critical areas and there's remote pump stations that are using radios. Okay, let's look at that first. So that would be, our recommendation is really, you really can't secure what you don't know that's what you don't know that you have that's connected to your network.
Gotcha. Great info, guys. Okay. I think that's about it. Next month, look out for, thank you guys for that great presentation. We appreciate it. Very enlightening about where it kind of opened my eyes to where we need to be. And a lot of people are, and I still think they're in the SCADA world, thinking that this is where they need to be. And you guys have shown us there's a whole new world out there, and maybe AI can help the operations, and that'll be a big step in the right direction, definitely. Okay, next month is thermoplastics and equipment for water and wastewater on June 16th, Wednesday. That is going to be by Hayward Flow Controls. They do a lot of plastic valves and filters and whatnot for your caustic materials like chlorination or other toxic chemicals that may need a special valve. So be sure to sign up for that. And then also, we'd love to hear your input. If we're not doing stuff on the webinars that you like, please let us know. If you like it, please let us know. Or also, if you have a presentation or a topic that you would like to know more about, let us know that too. We can get somebody scheduled up. Or even if you go back to Rockwell, if you want to know more about what they're doing, we can certainly reschedule them and delve more into the details of what they're doing and what the digital transformation would bring to your operations. So anything's on the table. So again, thanks, Rockwell guys. We appreciate your presentation, and we'll see you guys next month.
Great.
Thanks,
Ricky. Thanks, AWA.
Thank you.
Thank you.